In 2025, archaeologists discovered a concealed chamber beneath the Temple of Kukulkan, its walls covered in hieroglyphs showing celestial beings wielding impossible technology. Like finding secrets written in the stars, this revelation challenges everything we know about the Maya. How could a civilization without wheels or metal tools achieve such astronomical precision? New LiDAR scans expose entire cities hidden under jungle canopies, their layouts mirroring constellations invisible to the naked eye. The Maya's knowledge of Venus's orbit rivals modern software. So what explains their impossible accuracy? This video explores discoveries that even skeptics must confront. The answers may rewrite history. The 2025 LiDAR breakthrough. The 2025 LiDAR scans across northern Guatemala exposed more than 60,000 previously undocumented structures under dense jungle canopy. The airborne laser mapping technology penetrated vegetation to reveal pyramids, ball courts, residential complexes, and a network of raised limestone roads connecting urban centers. These scans indicate the Maya civilization supported a population between 10 to 15 million people during its peak, far exceeding previous estimates. The newly mapped structures display remarkable astronomical precision. Over 70% of pyramids and ball courts align within 2 degrees of key celestial events, solar zenith passages, Venus positions, and lunar standstills. The road system follows geometric patterns matching astronomical phenomena, with intersections occurring at lunar standstill points. This consistency across hundreds of miles suggests centralized astronomical knowledge. Building on these revelations, archaeologists identified 42 sites where architecture marks all 8 phases of Venus's 584-day cycle. The alignments remain accurate to within 0.5 degrees, matching modern astronomical software predictions. The Maya tracked these phases with such precision that their structures still mirror celestial movements today. The scale of urban planning challenges assumptions about Maya technology. LiDAR reveals an interconnected metropolis spanning 800 square miles in Guatemala's Mirador Basin. A network as carefully planned as a modern city grid. This zone contains reservoirs holding 200 million gallons of water, distributed through engineered canals. Elevated causeways measuring 130 feet wide were constructed without wheeled vehicles or metal tools. Construction techniques visible in the scans show sophisticated material understanding. Maya builders used crushed limestone for road foundations, layered with clay for water resistance. Pyramids incorporate core and shell designs with rubble cores faced by precisely cut limestone. Scans detect internal chambers and ventilation shafts, suggesting functional purposes beyond ceremony. Population estimates derived from LiDAR transform understanding of Maya agriculture. The scans show terracing and raised fields producing 2.5 times more food per acre than modern regional farming. Hydrological mapping reveals diverted rivers creating wetland cultivation zones while maintaining natural watershed patterns, requiring advanced topography knowledge. Moreover, the urban layout further confirms unexpected military sophistication. Nearly 20% of newly identified sites contain perimeter walls, watchtowers, and moats. One complex in El Zotz features 9 concentric defensive rings with inward-sloping walls designed to funnel attackers, contradicting earlier views of the Maya as purely astronomy-focused. Archaeologists have identified 14 cities appearing suddenly without developmental phases. Their complete urban designs, including water systems, roads, and astronomical alignments, suggest construction from pre-existing plans. No smaller settlements precede these cities in the scans. The LiDAR survey also detects puzzling anomalies. Near Tikal, 4 identical pyramids form a perfect 2.3 mile square aligned to within 0.1 degrees of true north. Each marks one of Venus's 8 phases, despite being built centuries before those positions recurred. Modern astronomers confirmed these alignments would only become evident after 400 years of observation. Excavations uncovered architectural models matching structures built centuries later. One limestone model depicts a pyramid with solstice light effects, impossible to predict without advanced solar geometry. Comparison with earlier scans shows the Maya intentionally obscured certain alignments. At El Mirador, later structures hid original astronomical markers from ground view, maintaining alignments only visible from elevated positions, possibly restricting knowledge to elites. The 2025 data also revealed 120-foot-tall observation platforms with sightlines to multiple celestial markers. One in Peton shows wear patterns suggesting regular use, positioned to simultaneously track Venus, Mercury, and Jupiter alignments. Precision in construction exceeds practical needs. Roads vary less than 1 inch over 5-mile stretches. Pyramid corners maintain 90-degree angles with under 0.3 degrees deviation, a consistency spanning hundreds of miles and centuries. Processing the data required new software to identify alignment patterns automatically. This revealed entire regions organized using astronomical geometry, with cities forming constellation mirroring triangles and pyramids marking stars invisible from ground level. The calendar that shouldn't exist. The Maya calendar system matches modern astronomical precision, functioning like a perfectly calibrated cosmic clock. A 2025 analysis of the Dresden Codex shows they tracked Mercury's 116-day cycle with 0.01% accuracy, equivalent to modern satellite measurements. These same records accurately predicted Mercury's retrograde motion, requiring observations spanning multiple orbital cycles. This precision extends to Venus, where their 584-day cycle calculations stayed within 2 hours over 6 decades. Their long count calendar operates on a 5,125-year cycle, aligning with Earth's 26,000-year axial wobble. A newly discovered stela at El Mirador confirms the Maya measured this gradual precession at 1 degree every 72 years, matching modern values exactly. Such accuracy seems impossible without precision instruments. Yet their calculations persist across all surviving records. The calendar structure reveals advanced celestial knowledge. Palenque's Temple of Inscriptions contains a mathematical sequence that inserts 11 intercalary days every 3 years to keep lunar and solar calendars synchronized, identical to the metonic cycle used in modern astronomy. Maintaining this precision would require centuries of moon phase tracking. A 2025 Codex discovery shows the Maya developed correction tables for planetary movements, including adjustments for Mars' elliptical orbit, a complexity European astronomy wouldn't solve until Kepler in 1609. The tables account for orbital velocity variations up to 6.5%, demonstrating mathematical sophistication beyond simple observation. The calendar's base 20 system could represent numbers up to 10 to the power of 60. Merchant records from Tikal reveal commoners use these large numbers for everyday transactions, suggesting widespread mathematical literacy. This numerical prowess enabled their astronomical achievements. Eclipse prediction tables in the Dresden Codex cover 33 years with 85% accuracy over millennium-long projections. NASA engineers confirmed these tables account for the 18-year Saros cycle and lunar orbital variations, knowledge requiring generations of continuous observation. New mural fragments at Köppen depict astronomers using simple cross staffs. Modern recreations show these tools could achieve documented accuracy when paired with mathematical tables. Standardized observation protocols apparently existed across multiple cities. The mysterious 819-day cycle was recently decoded as part of a 16,380-day framework synchronizing all visible planets' movements. This system tracks planetary stations, points where planets appear to reverse direction, with Mercury, Venus, Mars, and Jupiter returning to identical celestial positions. Architectural alignments at Chichen Itza correspond to calendar milestones. The Temple of Warriors' 365 niches match the solar year, while the Caracol's windows align with Venus extremes. 2025 radar scans revealed hidden passages forming sightlines accurate to 0.25 degrees for solstice observations. Practical applications show the calendar's sophistication. Madrid Codex planting almanacs divide the year into 20-day segments predicting soil conditions and rainfall within 5% accuracy, confirmed by 2025 soil core studies. Astronomical knowledge directly influenced architecture. Exact excavations uncovered residences where doorways framed sunrise positions impossible to see without optical aids or inherited solar geometry spanning generations. The Popol Vuh creation narrative contains numerical references matching calendar cycles, with verb tenses, encoding orbital period mathematics. Its 26,000-year creation cycle mirrors equinox precession. While skeptics suggest accumulated observations created the calendar, Nakbi's foundational structures from 1400 BCE already contain full calculations, showing no developmental stages. Modern Maya communities preserve this knowledge orally. 2025 recordings show elders reciting planting dates identical to pre-Columbian texts, demonstrating the system's resilience across 2,500 years. This living tradition challenges conventional ideas about how complex astronomical knowledge develops and endures.